Assalamu alaikum students. I'm teacher from Ilm Online Academy. In today's lecture, I'm going to discuss tree diagram from your chapter number 14 probability IGCSE syllabus. So tree diagrams as well is like quite important in the concept of probability, and you might have seen like in past papers, mostly the concepts are related to the tree diagrams. Okay, so this exercise is quite important and you need to practice as well. So, first of all, tree diagrams, a very basic concept you can get from my previous lectures in exercise 14.2a and 14.2b. So, in those, I just gave some very basic concept about the tree diagram where we use like the tree diagram for making for different coins, possibilities, and the others as well. But here we will go with the depth and we will just go in knowledge for more of the concept. So tree diagram is not quite difficult, but here we need to go with the two concepts that are basically important. One is with replacement and the one is without replacement. Without replacement. With replacement and without replacement. From the word as well, you might be clear that what is basically the meaning of the with replacement. With replacement means like, for example, you have some balls in the bag. Some are the blue one, some are the red one, blue, red, blue, okay? So you want to pick up a ball randomly and you want to find out the probability, okay? For example, you got the ability of picking up one red ball or two red balls. Now you want to find out another probability from the similar box, but you want to find out the probability in this way that you, whatsoever the balls you have picked up before, you put it back and then you found the probability again. Okay, the balls that you were taken out, so you need to put them back and then you will find out the ability. So that is basically called with replacement, that whatsoever the ability you have got at the very start. For example, if I will find out the blue balls probability, I have three blue balls out of total six balls, so this is my first probability. But for example, I want to find out the red balls probability, but I'm just putting back the blue balls and then I'm finding the red balls. For example, how many red balls? Three red balls are there again out of total six. So this basically called with replacement. Okay, here we are replacing it back and then finding the total probability will not be changed. The basic concept is this, that your total probability will not be changed. Your total outcomes will be similar. Okay, if we will be talking about the without replacement concept, so here, for example, you have taken the one blue ball and you're not replacing it back and you're picking another. So obviously your total probability will be changed. Like you have taken this one. So how many balls are remaining now? Five. So the next probability that you will be finding out will be according to the five balls that will be in the box. Okay. So this concept is important in this exercise, that is tree diagram. So according to these concepts, we will be just moving towards the tree diagram. Let's go on exercise 14.4a. So this quite lengthier exercise is, so according to this, I will check that if I needs to just make the two of the lectures or one. So you can just check in the next one video then. So 14.4a, in the first question, here they have drawn the tree diagram already. Okay, sometimes they will give you the tree diagram already and sometimes you need to draw it as well. So both concepts will go side by side. So what they are saying that a bag contains 10 discs, 7 are the black one and 3 are the white one. So total basically the discs are 10. So accordingly, if you will be finding the probability, you will be finding according to 10 discs probability. Okay. So next they're saying a disc is selected and then replaced. They are saying disc is selected, then replaced. So this basically question is with replacement. This question is according to the concept of with replacement. They are replacing it back. It means that your total probability for the next draw will not going to change. Okay. Here you can check, like for the first one, they wrote 7 by 10 because 7 are the black balls and 10 are the total discs. So I'm saying balls, sorry, these are discs. Okay. So 7 out of 10, basically the black balls, black discs are there. Next, for the next draw, your again we need to write down the black balls or black disk probability. So again, like the with replacement they're talking about, so 7 are the black disks out of total 10. So here the total probability is not going to be changed. Fine. So this is basically called with replacement concept. Next, what they're saying, a second disk is selected. Copy and complete the tree diagram showing all the probabilities and outcomes. Find the probability of this and this. Okay, fine. Before going on with the probability of A and B part, we must first find out like the probabilities on this tree diagram. We will complete this and then we will further move on. So first two probabilities they already gave, like 7 are the black balls out of total 10 and 3 are the white one. So 3 white discs out of total 10. As this question is like they're less replacing it back, so your total probability will not be changed. 3 by 10 will be white balls probability. Here they wrote 3 by 10. So this probability will be 7 by 10 because they're talking about black over here. This was white, but this was black. Next, white probability. So again, 3 over 10. So our tree diagram is completed now. According to this tree diagram, now we will be going on with A and B part. So in A part of question number 1, what they are asking is both disks are black. We need to find the probability of both black disks. Okay, so both black discs means like where you are having two black discs. In the first drawer, we have black and black. So 7 by 10 times 7 by 10. Okay, we need to just multiply. Just keep this in your mind that when we are using the tree diagram, within one branch, we will multiply, and with different branches, if they are asking multiple things, so we need to add them together. Right now, like they are asking for the one single branch, so that's why I'm going to multiply. So 7 times is 49, 10 times will be 100. Okay, so 49 over 100 is basically the probability of both black discs. Next, B part, they're asking both discs are white. So both discs are white is this probability. One white disc, second as well as the white disc, okay? So probability of both white discs. So one white disc is with 3 by 10, second white disc as well as with 3 by 10. So 3 times 9, 10 times is 100, okay? So this is the probability for the two white discs, okay? So you can see like this is like very simple concept that they gave at the very start, completing the tree diagram with replacement, and after that just finding out the probability. So side by side we will be checking for the next questions what they're asking for. But if this question is clear, then inshallah you will be going to have the understanding for the others as well, okay? Moving towards the second part, what they're saying that a bag contains 5 red balls and 3 green balls. So first of all, here they haven't gave us the tree diagram. So we need to draw the tree diagram. First of all, now for question number 2, first of all, the total balls we will see. So total balls are 5 plus 3, they are 8, okay? 8 total balls. 5 are the red one and 3 are the green one. So if we will be going on with the probability of the red balls, they are 5 over 8 and the probability for the green one are 3 over 8. Okay. So accordingly, now we need to draw. First of all, we will see that how many balls we need to draw or how many possibilities there will be according to. Because we need to draw the branches if they are asking for the 2 draws, 3 draws, so accordingly we will draw them. Okay. So first of all, they're saying draw the tree diagram, show all the possible outcome, find the probability of 2 green ball. First ball is red, second is green. It means that here we need to go with the 2 balls picking up. So 2 branches will be there. So we have 2 possibilities. One is for the red one is for the green one. Secondly, as well, the red one and the green one. Here as well, the red one and the green one. Okay. So now according to this, we will be just going on with this. So I'm just going to make it a bit wider so that you must be clear. Red and the green. Here as well, red and the green. Okay. Now above that, we will be writing like all the possibilities. So as they're saying the ball is drawn and then replaced, so it means that your total probability will not be affected. Okay. So red ball possibility or probability is 5 by 8 and the green ball probability is 3 over 8. Now next we need to write the red ball again. So as they are replacing it back, so that's why 5 by 8 again. Your total balls will not be changed. So as the previous one were also 5 red balls, so now there will be also 5 red balls. Okay. Green one will also not going to be changed. 3 by 8. This will be also 5 by 8. This will be also 3 by 8. Okay. Your probabilities for total one and the separate number of balls will also be similar. Okay. Hope so tree diagram is clear. Next, we need to go on with the A part. And in A part, what they're asking for is 2 green balls are drawn. Probability of 2 green balls. Okay. 2 green balls are here and here, right? So the probability for the first green ball is 3 by 8 and for the second as well is 3 by 8. So 3 over 8 times 3 over 8, this will be 9 over 64. Okay. Probability of 2 green balls. Next, for the B part, what they're asking for is that the first ball is red and the second is the green. Here they gave us an order. Like the first must be red and second will be the green one. Okay, so accordingly we will be checking. So if we will be checking for the second one, let's see. So first is the red one here and the second one is the green one. So accordingly we will be finding the probability. Okay, so B part, probability of first red and second green. So accordingly, the red ball probability is 5 by 8 and the green ball is 3 over 8. So 5 3 times is 15 and 8 times is 64. So this is the probability. So sometimes they can ask according to an order as well, like first must be the green, second is the blue one in this way. Otherwise, if they are not asking, then you can pick up like whatsoever the probabilities you are having in different ways, so you need to add them. As I'm saying that within one branch you will multiply the probabilities, but when we are moving with different branches, so you will add the probabilities together. Okay, so this is completely your part number 2. Hope so this part is clear. Here we have drawn the tree diagram ourselves. Next, moving towards part number 3. So in part number 3, what they're asking that a bag contains 7 green discs, 3 are the blue discs, a disc is drawn and not replaced. A very important concept. Here we are not going to replace it back, and without replacement, we are going to pick up another one. Okay, so your total probability will be changed. So they're saying a second disc is drawn to complete the tree diagram and then find out the probability. So first we will complete the diagram. So let me zoom in a bit. Here we can check. We have the green ball. Green disk probability is 7 over 10. Now, as they're not replacing it back, that's why out of 7, there will be only 6 green balls are remaining because here we picked up already 1 green ball. And out of 10, there will be only 9 remaining. If we will be talking about the blue discs, as we have picked up the green, so blue disc will be completely 3, but the total probability will be 9 then. Okay, because we have picked up 1 green one and we haven't replaced it back. So accordingly, 3 by 9. Next, for the second one, 3 by 10 was the probability for the blue discs. And as we have picked up the blue one, green disc will be 7. They will not be changed, but your total probability will be changed because one blue one we have picked up already. Okay. For the next one, as 3 was there, 1 was picked up, so 2 will be remaining out of total 9. So you can check like for the second draw, I have just changed my total probability, and if I am just going to take exactly similar one, so I'm going to change the numbers for that as well. Okay, so this concept is according to without replacement. So next in the A part, we need to find the probability both discs are green. Probability both green discs. So green discs here and here. First is 7/10. Next is 6/9. Simply you need to multiply together. One thing that in tree diagrams, I will suggest that don't go with simplifications like canceling out the numbers and then multiplying. Just multiply them together and just find out the answer. I will show you in the exercise as well. They gave you the hint like here anywhere that you don't need to simplify it, because sometimes this happens that we need to go with different branches and we need to add. So for addition, we must have the similar denominator. So for that reason, we will not simplify, okay? Otherwise, if you are doing the simplifications as well, that's also fine, okay? There is no rush for that as well. So 7 6 times 42 and 9 10 times will be 90. So this is the probability for question number 3, part A. Okay, next for the B1, we need to go both discs are blue. Probability, both blue discs. So the blue one here and here. So for that, 3/10 times 2/9, 6/90. So this is the probability that both discs are going to be the blue one. Okay. So part number B as well is done. This is your question number 3. Hope so this as well is clear. Moving towards part number 4. So here next and after number like part number 4 and onward, they haven't gave us the tree diagrams. We need to first draw the tree diagram and then we are going to head towards the probabilities. But sometimes students used to do this, like they are not they are habitual of like drawing the tree diagrams again and again, and after that when they have a clear concept, they no need to draw like the tree diagram. They used to skip and they used to find out the probabilities directly. But I will suggest, like, if you will draw the tree diagram, especially with not replacement questions, so it will be better, okay, without any mistake. If we will do the questions, so it will be better. So going on with the fourth part, what they're saying that a bag contained 5 red balls, 3 blue balls, and 2 yellow balls. So this time we have 3 different colored balls, 5 red, 3 blue, and 2 yellow. So first of all, for question number 4, if I will check the total balls, 5 plus 3 plus 2, 10 balls, okay? They're saying a ball is drawn and not replaced. Like we are going to draw a ball, but we're not going to replace it back. Then a second ball is drawn. So accordingly, we need to find. So first of all, we will complete the tree diagram. 2 balls we need to just go on with. So this time we are going to have 3 balls. So red, the blue one, and the yellow one. Second drawn, red, blue, yellow, red, blue, yellow, red, blue, yellow. Okay, red, blue, yellow. In this similar order, you need to write red, blue, yellow, red, blue, and the yellow one. Okay, so now we need to write down the probabilities. As they're saying not replace, so accordingly we will be checking. Okay, they're not going to replace it back. It means that your total probability will be affected. Okay, so first of all, red ball probability. Red are the 5 balls out of total 10. Blue are the 3 balls out of total 10. 2 are the yellow balls out of total 10. As first red ball has been drawn. So obviously your 4 balls will be remaining for the red one and your total probability will be 9. Out of 10, there will be only 9. For the blue one, we haven't picked up the blue yet, so that's why 3/9. Yellow we haven't picked up, so 2/9. Total probability will be changed, okay? Now the red one, so as blue one was picked up, so red one probability will be similarly, we will be writing 5, but out of total 9. Blue one, as we have picked up one blue, so 2 will be remaining out of total 9. Yellow will be 2 out of total 9. Here we picked up the yellow one first, so red one will be similar 5/9, blue one will be similar 3/9, but the yellow one will be 1/9. So in this way, you can complete your tree diagram. So hope so this one is fine. Next, moving towards the questions parts, like A part is probability of 2 red balls. Probability of 2 red balls. So red balls probability, if we will see, here we have 1, here we have 1. So One red ball is with 5 by 10. Second red ball is for 4 by 9. 5 4 times is 20. 10 9 times is 90. 20 over 90. Okay. If you want to simplify, then cancel out the zeros, and 2 by 9 is your probability for 2 red balls. Okay. Next, the B part is 1 blue ball and 1 yellow ball. Here, they're not saying the first one must be blue and second one will be yellow. So in any order, we need to pick up. So we need to check how many orders we are going to get. Accordingly, we will multiply it according to some numbers. Okay. So we need to move on. The blue ball, 1 blue and 1 yellow. So here you can check blue, yellow, yellow, blue. Okay, here we are not having yellow and blue or blue or yellow. Okay, so accordingly to probabilities we are getting, so we need to check it carefully. B part, probability of 1 blue, 1 yellow. Okay, so first one is blue, one is 3 over 10 times it by 2 over 9. As I told you, like within one branch, you will multiply it with different branch, you needs to add. So that's why second possibility that I'm getting, I needs to add it over here, okay? Yellow ball 2 over 10 and the blue 1 over 3 over 9. Now you can check that why I was saying that there was no need to simplify. So 3 2 times is 6, 10 9 times 90. 3 2 times 6, 10 9 times 90. Here we can check like we have the similar denominator, like these two are like fractions. We can just directly add them together. 6 plus 6, 12 out of total 90. So 12 by 90 is basically your probability for this. Okay, so after this, like you can simplify at the end, but at the very start, there is no need to go on with simplifications. One more thing, like here, if you want to go, like two similar numbers we are having, like above we have 3, 2, 2, 3, 10, 9, 9, 10. So what you can do is like whatsoever the possibilities you are having, like here I have two possibilities. If we have 3 or 4, you can find only one and you can multiply with the numbers. So that's also fine. Okay, sometimes we can do it this way as well. Next, C1 is 2 yellow balls. Probability of 2 yellow balls. So let's go on with 2 yellow balls. We will see where we are getting the possibility accordingly. Let me erase these so you will be clear that which possibilities I'm picking up, okay? So as we need to go with 2 yellow balls, one yellow is right here, one yellow is right here. So simply he needs to pick up these two, okay? So one yellow ball probability is 2 over 10 and second one is simply 1 over 9. So 2 1 times 2, 10 9 times is 90. If you want to simplify, this will be 1 over 45. Now moving towards the D part, they're saying two balls of the same color. Okay, one is already been picked up, yellow, yellow. Next will be blue, blue. Next will be red, red. Okay, so accordingly we will picked up. Probability of same color ball. Okay, first one is the red, red. So 5 by 10 plus, no, plus. Right now we'll multiply within branch. 5 by 10 times 4 over 9 plus. Next, 3 over 10 times 2 over 9 plus 2 over 10 times 1 over 9. So within branch, we need to multiply. With different branches, we will add. So 5 4 times is 20 over 90, 6 over 90, 2 over 90. Now we need to add all these numbers together. So 26 and 2, 26 and 26 and 2 will be 28 over 90. So in this way, we have multiple branches, so we need to add the probabilities of different branches, and in this way, we will be getting the probability of the two same colored balls. Okay. So these were the four parts, D parts up till D, we have done for question number 4 as well. So hope so this as well is clear. Okay, now moving towards the fifth part, they're saying a bag contain 4 red balls, 2 green balls, 3 blue balls, and a ball is drawn and but not going to replace. So second ball is drawn and we need to find the probabilities accordingly. Again, here we are going to draw the tree diagram. So let's go on with So for drawing the tree diagram, we have red, blue, and green. Red, green, blue. Green, the blue. Red, green, blue. Red, green, and blue here as well. Okay, just try to draw the tree diagram a bit wider so that you can easily write down your possibilities. Red, green, blue, red, red, then green, then the blue one. Okay, so above this, we will be writing the possibilities whatsoever we are going to have. So here again, similar condition, not replacing back. If not replacing back, so accordingly, we will find out the best probability. First probability for the red ball will be 4 over total balls. Total balls I haven't wrote. So total balls, if we will be writing, they are 4 plus 2 plus 3. 9, okay? 9 total balls. Accordingly, your probability will be 4 over 9 for the red one, 2 over 9 for the green one, 3 over 9 for the blue one, okay? Next, as not replacing back, so if one red has been picked up, 3 will be remaining out of total 8. Green will be similar 2 over 8. Blue will be similar 3 over 8. Okay, your total probability I've changed. Next, the green one has been picked up. So blue one will be similar but 4 over 8. Green one will be changed. That will be 1 over 8. Blue one will be similar but 3 over 8. Okay, total possibilities I've changed. Next, for the red one, 4 were the red one. So accordingly, 4 over 8. The green one will be 2 over 8, but the blue one will be changed. This will be also 2 over 8. So in this way, we have completed the tree diagram. After completion of the tree diagram, now we will be heading towards the A, B, C, and D parts for these. So moving towards the A part, what they give in this, 2 blue balls probability. Probability of 2 blue balls, okay? So first blue ball probability, if we will be checking here, first blue ball is here. Second blue ball is here. They're talking about the blue ball first, so we will be finding out the probability of the blue balls first, okay? First is coming 3 over 9 and the second is coming 2 over 8. So 3 2 times is 6, 9 8 times is 72. This is your probability for the blue balls, 2 blue balls. Next, the B part. What they are giving in this? 2 red balls. Probability of 2 red balls. So one red ball probability at the start this, second is this. So 4 over 9 times 3 over 8. 4 3 times is 12. 9 over 8 will be, 9 times 8 will be 72. Okay. Okay, one more thing. Like if we have all these different possibilities or probabilities here, and if I'm going to add all these probabilities together, I'm going to get 1. Because your total probability always adds up to 1. So this thing as well you need to keep in your mind side by side. Next, C1 is 1 red and 1 blue ball. Here they're not specifying that which order we need to take. So you need, whatsoever the orders you are getting, you need to take them all, okay? 1 red, 1 blue. Red, let me choose any other color. Red, blue. Blue, red. 2 different possibilities we have over here. Accordingly, we will work, okay? C part. Probability of 1 red, 1 blue ball, okay? 1 red ball probability is 4 by 9 and the blue one is 3 by 8 plus 3 by 9 times 4 by 8. So 12 over 72 and this will be also 12 over 72. 12 and 12, if we will add them together, this will be 24 over 72. Okay, after that, if you want to simplify, then you can go on with simplification. Otherwise, you can leave it right here. This is your part number C. So moving towards the part number D here, they're saying 1 green ball and 1 red ball. Okay, this time we need to go with the probability of D part. 1 green, and 1 red. Okay. So accordingly, if we will see, I'm just erasing these. One green, one red. Green and red. Red and the green one. So here I can show you, like, if like I was saying, that if you have similar things together, so you can just multiply it by 2. Red ball is 4 by 9 and the green ball is 2 by 8. Any one you can pick up, either from this branch, either from this, because we are going to have the similar possibility, so you can simply multiply it by 2. So here 2 will be cancelled out with the 2 in this. No, sorry. These are in the numerators. So 4 2 times 8. 8 2 times will be 16 over 72. 16 over 72. So this is the probability for the 1 red and 1 green ball. Okay. So this is your part number 5. I hope so this as well is clear to you. Now moving towards the 6th part. In part number 6, what they are saying, that a 6-sided dice is rolled 3 times, and draw the tree diagram showing that each branch has the 2 events, 6 or not 6. Like we are interested only in getting 6 or not 6 probability. Like if we will be talking about the dice, we have total 6 possibilities, 1 2 3 4 5 6, up till 6. But here they're saying you will draw the tree diagram, but you are going to have only 2 events on that, either getting 6 or either getting not 6. So what is the probability of throwing a total of 3 sixes, no sixes, 1 sixes, or at least 1 6? If they're asking for the total of 3 sixes, it means that we needs to go up till the third branch. Here as well, they're saying the 6-sided dice is rolled 3 times. It means that we needs to go up till the third branch. Okay, but the possibilities will be only 2. Okay, so question number 6, getting a 6, getting not 6. First draw 6, not 6. Again 6, not 6. Again 6, not 6. Here as well 6, not 6. Here as well 6, not 6. This is our third one. Okay, this as well will be with 6 and not 6. Now we will draw the possibilities. Like, what is basically the probability? We have total 6 possibilities, and probability of getting a 6 on a dice will be 1 over 6, because only one time we can get 6 out of total 6 possibilities, and probability of getting not 6, if we will be finding out, so not 6 probability will be 1 negative 1 over 6. So this will be 5 over 6, right? 5 over 6, because we must know the probability of getting 6 or not 6. If we have one probability and we want to find out the probability of not happening that event, so you need to simply subtract it from 1, because your total probability is 1. Okay, so accordingly we will write the possibilities over here. But here there is no concept of picking up or picking not, like with replacement and without replacement concept is not over here. Okay, getting 6 probability is 1 over 6, not 6 is 5 over 6. 1 over 6, 5 over 6. 1 over 6, 5 over 6. 1 over 6, 5 over 6. 6, 5 over 6. Okay, tree diagram is done. So moving towards part number A, they're saying we need to find the probability of getting 3 sixes. A part, probability of 3 sixes. 1 6, second 6, third 6. So 1 by 6 times 1 over 6 times 1 over 6, because I'm moving to within one branch. I'm going to multiply all these together. Okay, all the probabilities of getting a 6. So 6, if we will multiply 3 times, this will be 216. Okay. Next, probability of getting no sixes. No success probability as well as like similarly here, 3 times the root, 1, 2, 3. So accordingly, we'll pick up last 3. So probability is 5 over 6 times 5 over 6 times 5 over 6. This will be 125 over 260. Okay, C1 is getting 1/6. Only 1/6 for probability. So 1/6 probability, if you want to, it means that 2 not sixes and 1/6. Okay. So if I will just check them accordingly, 1/6, only 1/6, not 6, 6, not 6, only 1/6. Okay. Not 6, not 6, 1/6. 6, not 6, not 6. Rest all have at least 2 sixes. So just 3 possibilities we are having. 3 different possibilities. But if you will see, 1 over 6, 5 by 6, 5 by 6, 5 by 6, 1 over 6, 5 by 6. Similar possibilities we are having. And as we need to multiply it together, so there is like no needs to go with the finding all these 3 separately and then adding them together. Simply multiply it by 3. One probability, multiply by 3. C part, probability of getting 1/6, only 1/6. So multiplying it by 3, first probability 1 over 6 times 5 by 6 times 1 over 6. No, sorry, 5 by 6, because 1 is only 1/6 and rest 2 will be 5 by 6. Accordingly, if I will be checking 5 times will be 25, and 25 needs to be multiplied by 3. 75 over 260. This is your probability, okay? Next, moving towards the D part, and in this D part, they're asking at least 1/6 use part B. Yeah, this is very important. Like mostly they gave the concept like this in the past papers as well, I've seen. At least 1/6 probability if they're just asking us to find out. So you can check like in B part, we got the probability of no sixes. No sixes probability was this last one where we were having all not sixes probability. If I will subtract all these not sixes probability, you can check rest all are having at least 1/6. Rest completely branch is having at least 1/6. Just this branch is having not 6. If like the total probability I told you is equals to 1. And from the total probability, if I will subtract this not sixes probability, so I'm going to get at least 1/6 probability, because it will take so much time if I will just find out, because how many branches we have? 1, 2, 3, 4, 5, 6, 7 almost, okay? And here we are not having the similarity, like just the way I was multiplying by 3 in the C part. This will not be happened over here. So this will be better. Here, like they mentioned that you can use the part number B. This is a hint that you can use, but in exams they will not. So this you need to check yourself. Like if you have the total probability already, you know the total probability is basically always equals to 1. If your total probability is 1 and you want to find out at least 1/6, rest all are having 1/6 rather than that of this last one. So we are going to use the part B. The probability that we got, we are going to subtract it from 1, okay? D part. Probability of at least 1/6. So from 1, we are going to subtract this 125 over 216. Take the LCM. 216 negative 125. Subtract this. So I'm getting 91 over 260. 91 over 216. This is the probability of getting at least 1/6. Okay. So this is your completely part number 6. Hope so this as well is clear. Now moving towards part number 7. So in part number 7, what they're saying that a bag contains 6 red marbles, 4 blue marbles. So two types of marbles are there, red and the blue one. Then they're saying a marble is drawn at random and not replaced. They're drawing a marble and they're not replacing it back. It means that your total probability this time will be changed. Total, your marbles are 10. So they're saying two further draws are made. First of all, they're drawing it, but they're drawing it two further draws. So it means that total draws are 3. Okay. And they're again without replacement. Again, they're not replacing it back. So we need to find the ability of drawing 3 red marbles and this and that. So first of all, we will complete the tree diagram. We have two types of marbles, the red one and the blue one. So 3 draws we will be going with red, the blue, red, the blue. Again, red, blue, red, the blue, red and blue. Here as well, red and the blue one. Okay. So let's find out the probability according to this concept without replacement. Total probability will be changed. Red marbles are 6 over 10. Blue are 4 over 10. First red has been drawn. 5 will be remaining out of total 9. Again we have to draw. So 4 will be remaining out of total 8. So in this way, like branch to branch, you need to just change your total probabilities as well and your red marbles probability as well. Next, red has been taken, so blue one has not been taken. So blue one will remain similar, but total will be changed. Again, red has been taken. So yeah, we need to move with this as well. Okay, blue one is remaining. So blue one, we haven't taken the blue one yet. So 4 will be the blue one out of total 8 here because 2 have already drawn. Okay. This we have done. Now moving towards the red, as one red has been already picked up. Okay. So 5 red will be remaining out of total 8. Clear? Next, the blue one blue has been taken. 3 will be remaining out of total 8. So very much careful, carefully we need to write all these possibilities. Next, the blue one has taken. So red has not been taken. 6 over 9. Red has been taken again. We need to go on with the red. So 5 over 8. Blue one has been taken. 3 will be remaining out of total 8. Blue one, again blue one. So 3 over 8. Sorry, 9. 3 over 9 here. Next again red has not been taken yet. So 6 over 8. Next, the blue one taken, again blue needs to take. So 2 over 8. In this way, we need to complete the tree diagram. So for this, like where we need to go with different possibilities at the end without replacement. So you need to be very much careful for the tree diagram. Okay. If your tree diagram is not fine, then your possibilities as well are not going to be fine. Moving towards question number 7. Okay, so what they're saying in the A part that we need to find the ability of 3 red marbles. Probability of 3 red marbles. 1 red marble, 2 red marble, 3 red marbles. So 6 over 10 times 5 over 9 times 4 over 8. Multiply the numbers together. We have 6, we have 5, we have 4. These all multiplications are going to give us 120. Multiplying 10, 10 with 9 with 8. It's coming 720. Okay. Next, part number B. 3 blue marbles. Probability of 3 blue marbles. Blue one are at the end. Blue. Okay. So 4 over 10 times 3 over 9 times 2 over 8. For 3 times and 12, 2 times will be 24 over 720. Okay. So this is basically 3 blue marbles probability. Next, C1 is no red marble. Okay. C I'm doing here. No red marble. No red marble is only at the end. Rest all are having at least 1 or 2 red marbles. So again, similar probability, we need to change whatsoever we have the blue one. 24 over 720. Okay. No red marble. Next, the D part is at least one red marble. Yes, similar concept here we have. Probability of at least one red marble. If one red marble, at least one red marble, they're saying, so you can check that. Rather than that of this last one, rest all are having at least one red marble. So again, we need to subtract the red marble probability from 1. Like this. Let's take the LCM. 720, 1 times 720, negative 24. So it's coming 696 over 720. This is basically your probability for at least one red marble. Okay. And this was quite similar to the sixth part. So you can just compare it with sixth part. And here we go with the seventh part as well. Hope so that's as well is clear. Okay. Next, moving towards the part number 8. So in part number 8, they're saying when a cutting is taken from a granium, the probability that it grows is 3 by 4. This is the probability of the growing. 3 cuttings are taken. So what is the probability that all 3 grows? None of them grows. Just 2 probabilities we need to tell them. First of all, we will draw the tree diagram. 2 things are there, growing probability and not growing probability. And we need to go up till 3 cuttings, okay? Grow, not grow. Grow, not grow. Grow, not grow. Again, third one, grow, not grow. Grow, not grow. Here again, grow, not grow. And the last one, grow, not grow. Now they gave us the probability of growing. Question number 8. Probability that it grows is 3 by 4. And if you want to find a probability of it like not grows, that will be 1 negative 3 over 4. Like from 1, we need to subtract 3 by 4. So let's subtract it and it will be 1 over 4. So accordingly, we will complete the tree diagram first of all. Okay, so first probability grows 3 over 4, not grows 1 over 4, 3 over 4, 1 over 4, 3 over 4, 1 over 4. Similarly, just you need to write it down. Okay, tree diagram is done. Next, A and B part we need to go with. So A part is all 3 grows. Probability of all grows. Grows, grows, grows. 3 over 4 times 3 over 4 times 3 over 4. 3 3 times 9, 9 3 times is 27, and 4 3 times multiplying with 64. Okay, 27 over 64. B part is none of them grows. None of them grow, not grow, not grow, not grow. Okay, so probability of none grows. 1 over 4 times 1 over 4 times 1 over 4. It will be 1 over 64. So this is the probability of not growing at all, okay? So hope so this as well is clear. This was your part number 8. So moving towards part number 9, in this they're saying a dice has its 6 faces marked as 0, 1, 1, 6, 6. Okay, this time they gave us the dice with different possibilities. Like we know the dice are having the probability as 1, 2, 3, 4, 5, 6. But this time they give 0, 1, 1, 1, 6, 6. Okay. What they're saying is the 2 of these dice are rolled together and the total score is recorded. 2 dice rolling probabilities basically is 36, like the total probabilities. We need to draw the sample diagram and how many different total possible outcomes are there. So we need to find that out. Different total possible outcome we need to check, and what is the probability of obtaining total of 7. Okay. So first of all, we need to draw it. So let's draw this. So we can draw the sample diagram first of all, just the way we have drawn it before, we are going to draw it similarly. Okay. There is no going to be change. Just the possibilities are going to be changed. Again, the sample diagram is must. Without this, like, it's difficult for you to understand the concept. And also, if you will not draw this one, so it will be hard for you to find out the answer without any mistake, okay? So we have different possibilities here, 0, 1, 1, 6, 6, so we'll write it accordingly. We have 0, 1, 1, 1, 6, 6. Similarly, 0, 1, 1, 1, 6, 6. Because here we have the possibilities according to this, so we will write this. So 0, 0, 0, 1, 0, 1, 0, 1, 0, 6, 0, 6. Next, 1, 0, 1, 1, 1, 1, 1, 1, 1, 6, 1, 6, 1, 0, 1, 1, 1, 1, 1, 1, 1, 6, 1, 6, 1, 0, 1, 1, 1, 1, 1, 1, 6, 1, 6, 6, 0, 6, 1, 6, 1, 6, 1, 6, 6, 6, 6. Okay. Next is 6, 0, 6, 1, 1, 6, 1 again. 6, 1, 6, 6, 6, 6. Okay. These are total 36 possibilities we have drawn. So they're saying how many different total possibles are there. Okay, like we need to check that how many possibilities are different over here. So accordingly, we will check it. So totals, different totals, if I'm going to find out, we can just write them over here: 0, 1, 1, 1, 6, 6, 1, 2, 2, 2, 7, 7, 1, 2, 2, 2, 7, 7, 7, 7, 2, 2, 2, 1, 6, 7, 7, 7, 12, 12, 6, 7, 7, 7, 12, 12. So we need to check that how many different possibles are there. So we need to find out, we got 0, we got 1, we got 2, we got 6, we got 7, we got 12. How many different possibles are there? 1, 2, 3, 4, 5, 6. 6 total different possible outcomes, okay? Yeah, other than that of this, we haven't got any different total. Next, B part is, what is the probability of obtaining a total of 7? Probability of total of 7. How many times we got 7? Total of 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times we got out of total 36. So this is the probability of getting the total of 7. Okay. So here, like, concept is similar, just the way we have drawn the dice before with different possibilities. But the thing is that here they gave some different possibilities. Accordingly, we just worked with the diagram and I got the possibilities. Okay. Now moving towards the 10th part, they're saying a coin is biased so that the probability of getting a head is 3 by 4. Find the probability that when it tossed 3 times, it shows 3 tails, 2 heads, 1 tail, and so on. So three possibilities we need to go with question number 10. They gave us the probability of getting a head, that is 3 by 4. We need to find out the probability of getting tail. I told you that if they give one probability, we need to find it for the second one after subtracting it from 1. So 4 negative 3, it will be 1 over 4. Going on with 3 draws, because they are saying 3 times the coin is being tossed. So head, tail, head, tail, head and tail. Again, head, tail, head, tail. I'm just going to draw it a bit wider. Head, tail. Okay. Accordingly, we'll just pick up some possibilities. So head 3 over 4, tail 1 over 4. 3 over 4, 3 over 4, 1 over 4, 1 over 4, 3 over 4, 1 over 4. Head is 3 over 4, 3 over 4, 1 over 4, 1 over 4, 1 over 4, 3 over 4. Okay. Tree diagram is done. So part number A, I'm going on with. They're saying 3 tails, probability of 3 tails. 1, 2, 3. 1 over 4 times 1 over 4 times 1 over 4 That is 1 over 64. Okay, 1 over 64. B part, probability of 2 heads, 1 tail. They haven't given any order. So any order you can pick up. 2 heads, 1 tail. Okay, let's find out where we are having 2 heads, 1 tail. 2 heads, 1 tail. 2 heads, 1 tail. 2 heads, 1 tail. 3 possibilities. So I'm going to use exactly similar way, multiplying it by 3 and finding the probability only one time. 3 over 4 times 3 over 4 times 1 over 4. 2 heads, 1 tail. 3 times 9, 9 3 times is 27 over 64. This is the probability of getting 2 heads and 1 tail. Okay. Next, part number C. Part number C is basically probability of getting 1 head and 2 tail. Probability of 1 head, 2 tails. One head, 2 tails. 2 tails, 1 head. 2 tails, 1 head. Again, 3 possibilities, okay? 1 head. Head probability is 3 by 4. 2 tails probability is 1 by 4 and 1 by 4. 9 over 64, okay? This is the probability for the part number C. Next, D probability is no tails. No tails we are getting only one time in the, like above over here. Probability D part, probability of no tails. Rest all are having at least 1 or 2 tails. So 3 over 4 times 3 over 4 times 3 over 4. That will be 27 over 64. Okay. This is your part number D where we are having no tails. So hope so up till 10 these questions are clear. So inshallah from next one lecture I'm going to continue with part number 11 and so on. So see you until the next lecture. Allah Hafiz.